Voyager 1, launched in 1977, is the most distant spacecraft ever sent from Earth. It is moving away from us at a speed of about 38,000 miles per hour, or roughly 11 miles per second, despite its staggering distance of about 15.5 billion miles from Earth. We are still able to communicate with it. So, how is it possible to send commands to such a distant spacecraft or receive data from it? And how much longer will we be able to stay in contact with Voyager 1? The launch and its mission. Voyager 2 was actually launched first on August 20th, 1977. Voyager 1 followed about 2 weeks later, lifting off on September 5th, 1977. Voyager 1 and Voyager 2 are nearly identical in design. Their mission was to explore the outer planets beyond Jupiter. Rocket engines alone could not provide the necessary speed, so mission planners chose a rare planetary alignment that allowed the spacecraft to gain speed by using the gravitational pull of multiple planets. Jupiter, Saturn, Uranus, and Neptune were lined up in the same general direction as seen from Earth. This alignment will not occur again until the year 2150.
Jupiter, Saturn, and beyond. Voyager 1 flew past Jupiter and Saturn, sending back breathtaking images along the way. This image shows the atmosphere of Jupiter. It also confirmed the presence of Jupiter's faint rings. Voyager discovered active volcanoes on Jupiter's moon Io. It then headed towards Saturn. There, it observed Saturn's rings from a close distance and discovered shepherd moons that help shape and maintain the rings. It also found that Saturn's moon Titan has a thick atmosphere composed of about 90% nitrogen. After that, Voyager 1 continued its journey toward the outer edge of the solar system. Voyager 2, which took a different path, flew by Uranus and Neptune, destinations that Voyager 1 never reached, and took detailed photos of both planets. Voyager 1 surpasses Voyager 2. After completing their planetary missions, both Voyagers continued moving farther away from Earth. Although Voyager 1 launched first, Voyager 1 is now farther from Earth because it is traveling faster. Voyager 1 is moving at about 10.6 miles per second, while Voyager 2 is moving at about 9.7 miles per second. That speed difference may not seem huge, just 0.9 miles per second, but imagine riding on the slower spacecraft as the faster one passes by. In just 1 second, Voyager 1 would be 0.9 miles ahead. Exiting the Heliosphere. The two spacecraft have now exited the heliosphere. The terms solar system and heliosphere have significantly different meanings. The heliosphere is the bubble-like region of space dominated by the solar wind. The solar wind consists of charged particles emitted by the sun. It forms a sphere around the sun. But as the sun moves through the galaxy, the solar wind is compressed in the front and stretched out behind, creating a bubble shape. Voyager 1 and Voyager 2 have both crossed this boundary and exited the heliosphere. This graph shows actual data from Voyager during that moment. The lower graph shows the number of solar origin particles dropping, while the upper graph shows a sudden increase in particles coming from interstellar space. So the heliosphere marks the limit of the sun's influence via the solar wind. The solar system itself is much larger. For example, the Oort cloud lies far beyond the heliosphere. The Oort cloud is a theoretical region filled with icy bodies and rocks surrounding the sun in a vast spherical shell. According to some estimates, it will take Voyager another 300 years to enter the Oort cloud and about 30,000 years to exit it. How we talk to Voyager. We can still send commands to the Voyagers and receive scientific data from them. But how is communication possible over such vast distances? Each Voyager has a dish antenna that is 12 feet across. This is the iconic feature most people imagine when they think of the spacecraft. The antenna emits a very narrow beam of radio waves with just 22 watts of power, the equivalent of a household light bulb. It takes about 22.5 hours for a signal to reach Earth. For comparison, it takes just over 1 second for light to travel from the Earth to the Moon, and about 20 minutes to reach Mars. This puts the Voyager's distance into perspective.
NASA's Deep Space Network. Radio waves weaken with distance, following the inverse square law. So by the time Voyager's 22-watt signal reaches Earth, it is faded to just a tiny fraction, less than 1/trillionth of a watt, and then another billionth of that. To detect such faint signals, NASA uses massive antennas. These antennas are 230 feet in diameter and are part of the Deep Space Network. The network is set up at 3 locations: California in the United States, Madrid in Spain, and Canberra in Australia. This ensures that at least one antenna can always see the spacecraft at any given time, enabling 24-hour communication. Besides the massive 230-foot dishes, each location also has antennas of various other sizes. Together they form a worldwide communication system designed to talk with spacecraft far beyond Jupiter. Thanks to these giant antennas, we can continue sending commands and receiving data from Voyager. Voyager's power source. But transmitting and running instruments also requires power. Voyager does not use solar panels because the sun is too faint at such great distances. Instead, it uses nuclear power radioisotope thermoelectric generators, which convert the heat from decaying plutonium into electricity. At launch, each Voyager produced over 400 watts of power. Now, after decades of flight, power output has dropped below 200 watt. To conserve energy, non-essential systems have been shut down gradually.
Voyager's final images and instruments. This is a photo of Earth taken by Voyager, our home, seen from nearly 4 billion miles away. It was the last picture Voyager 1 ever took. After that, its camera was permanently turned off to save power. Voyager 1 carries 10 scientific instruments. Only those measuring magnetic fields and charged particles are still in use. With just these, it continues to study the interstellar environment beyond the heliosphere. However, power output from the nuclear battery continues to decline. NASA is carefully planning when to shut down each remaining instrument. Even after all instruments are turned off, Voyager will still be able to transmit basic information like its location. Over the decades, the Voyagers have encountered some technical issues. Voyager 2's antenna problem. In 2023, Voyager 2 experienced a problem when its antenna drifted off by just 2 degrees. That may not sound like much,
But at billions of miles away, even a tiny angle shift is critical. It was enough to cut off communication entirely. NASA had anticipated this scenario. Voyager was pre-programmed to automatically correct its orientation a few times each year. Sure enough, it reoriented itself and communication was restored.
Voyager 1's software glitch. Voyager 1 also ran into trouble when a software issue caused it to send data through a deactivated computer. NASA spent months diagnosing the problem and eventually sent a new command directing it to use a working computer, resolving the issue. Preparing for future challenges. NASA is also planning for future problems such as thruster valve blockages. The Voyagers use small thrusters to maintain their orientation for communication. These thrusters fire in short bursts, unlike main engines, and over decades, propellant residue can build up and clog the plumbing. NASA updated the software to extend the duration of each thruster firing. This reduces the number of times the thrusters need to fire and is expected to extend their life by about 5 more years. Despite these challenges, both Voyagers continue their journey and maintain communication with Earth. However, as they get farther away, signal strength continues to decline. NASA expects that by 2036, communication will likely end. That means we have, at most, about 10 years left to communicate with Voyager 1. Voyager's legacy beyond expectations. Voyager 1 and Voyager 2 were launched in 1977. Their mission was originally planned to last only 5 years. However, they have been operating for more than 40 years, far exceeding the initial plan. They have left the Heliosphere and continued to send data back to Earth. The memory capacity of the Voyagers is about 13 millionth of that of a modern smartphone. Their communication speed is about 138,000th of today's standard. Although the technology was state-of-the-art at the time, it has now become outdated. Despite carrying old equipment, these probes have reached the farthest points from Earth and represent the forefront of space exploration. By transmitting very weak radio signals, they stay connected to Earth and will continue to travel through unexplored space in the future.